What's up, everyone? So the first video that I think we're going to do two again this week. The first one is our last lesson dealing with logarithms and exponentials. The lesson after this is going to be our first lesson with trigonometry. So we'll probably do what we did last week and do two videos. I got to set my timer. So I forget it's 1:30 now on a Sunday. Hopefully I have this done before 2 o'clock. All right, so if we were in school, you would have had a test on all that log stuff. And this would have been the first lesson of test 6. And it's mathematical modeling. You've done modeling in the past in algebra. You did linear modeling. All right, linear modeling is just that. It's y equals mx plus b, or point slope. So y minus y1 equals x minus x1. That'd be your linear model. Usually used if you're not taking calculus, stats is probably what you're going to be going towards. You would be using linear modeling in stats. More than likely, you're going to be basing it off some points. You're going to use that second equation. The other one was quadratic modeling. Oop. Yeah, let's change my visual setting so it works better. So quadratic, let's spell it right. Quadratic modeling is a parabola shape or some kind of shape like that. So y equals ax squared plus bx plus c, or you can have the vertex form. So y minus k equals ax minus h squared. So again, that's something else you might see in stats. However, more than likely, the one that you would see most of all would be exponential growth, exponential decay, exponential modeling. Like, that happens a lot, especially right now. You can think about the stuff that's going on. They're hoping that there's some kind of exponential curve, but personally I feel they're more looking at a quadratic model because they're looking at something kind of leveling out and going back down. So for me, that'd be something like that. But let's get to exponential. So the exponential model actually has e in it. So it's y equals y sub 0 e to the kt. So this is really related to the continuously compounding interest formula, where y sub 0 is your initial amount. E, again, is just a number on your calculator. K is the constant of growth or decay. Right? It's growth if k is greater than 0, and it's decay if k is less than 0. And t is just time. And we usually do it in years. Ugh. All right, so those are the 3 different models we're going to be looking at. That you could have. The one we're really going to be looking at in this video is just exponential. Okay, so I'll give you some time to jot that down, or maybe just pause the video if you need to. One thing to point out, the initial amount, if you say you don't know it, right, but you can find it. You find the initial amount when time is 0, okay? Just a thing to keep in the back of your mind. All right, so that was part 1 of the lesson. Part 2 is going to say, like, find the equation of each exponential curve. So you're going to be given something like this. You have the graph given to you. Well, if it's an exponential curve, that means we're dealing with the equation y equals y sub 0 e to the kt. So now we kind of fill in what we know. We know the initial amount. And the way we know the initial amount is when t is 0. Because really, this is, oh, let me use it here, the t-axis and the y-axis. So my initial amount in this graph is 1. So I can rewrite my equation y equals 1 e to the kt. And really what your goal is here is to figure out, using the other point, what k is. We need to know what k is because that's going to give us our equation. T is the variable. It's like x, right? Time goes on, all right? And y is our dependent variable there. It's what's going to be changing. So we're going to use our second value, 2 and 11. So that's my t and that's my y. So I'm going to say 11 equals, I'm not even going to write the 1 because we don't need to, e to the k times 2. All right, so my goal again, to solve for k. So to get that thing down, the exponent down, we have to ln both sides. So we're doing natural log. Okay, so we get the ln of 11, which is some kind of decimal, I don't know, equals 2k. All right, divide both sides by 2. And we get k to be about something. That something, I don't know what it is. So I grab my calculator, plug in ln of 11, divide by 2. Looks like 1.199. 1.199. In this case, this is exponential growth because this is positive, like we said before, if k was greater than 0. So our equation, or the model, would be y equals 1e to the 1.199t, or if you don't want to write the 1, because that's a 1, it's not an L, y equals e to the 1.199t. Either one of those, perfect answer. All right, so this again is when you'll be given a graph. So we're going to try another one with the graph. It's just going to be a decay problem. So hopefully our k comes out negative because that's what it said for the information we were given. Again, if I'm going too fast, pause the video, jot it down. If I'm going too slow, just watch this on double speed, which I know some of you have already done, which I don't know how you do it because I wouldn't be able to write that fast. But hey, maybe I just talk too much. All right, same idea. Y equals y sub 0 e to the kt. Need to know our initial amount. We totally know our initial amount. It's 2. Okay, so if our initial amount is 2, we get y equals 2e to the kt. Now we use the second point just like we did before, which was 3 1/2. Oh no! So I'm going to say 1/2 equals 2e to the k times 3. Okay. And so now we go through, we solve for k. Divide both sides by 2. So I get 1/4 is e to the k. Let's put 3k instead of k3 because that's weird. And to get that variable down, we got to ln both sides. So I get the ln of 1/4 equals 3k because the ln and e cancel out. Divide both sides by 3, and we get k to be approximately some decimal that I need to plug into my, oh no, calculator. Ln of 1/4 divide by 3. Look at that, negative, which is what we wanted, 0.462. So now we write the model. Y equals 2 e to the negative 0.462 t. That'd be our answer. So I have one more to do. We're not going to have a graph with this one. I'm just going to give you a t-chart because you don't necessarily need the graph. Like, those are, well, t and y coordinates, just like x and y coordinates. So I could give you just, I guess I should change this from an x to a t, y coordinate. All right. We do the same exact steps. Right? Initial amount is when t is 0. So I know it's 4. So we get y equals 4 e to the kt. And then I just plug in what I have when I solve for k. So I have 52 equals 4 e to the k times 3. And 52 divided by 4, I think it's 13. E to the 3k. ln both sides. And then divide by 3. So k is approximately whatever the ln of 13 is divided by 3. So ln 13 divided by 3, get 0.855. So my model, y equals 4e to the 0.855 t. And there it is. You would approach all these problems exactly the same way. All right. So the next few problems are actually from your textbook. So if you have your textbook, they're on page 266 and 267. I did take pictures of them, so they are on the next pages here. But a lot of times when you talk about mathematical modeling, you're dealing with word problems. Okay, so here's page 266, number 37. And it's talking about website growth. So it says the number of Y of hits in a new search engine website receives each month is modeled by, and it gives the equation Y equals 4080 e to the kt, where t is the number of months in this case the website's been offering, and the website's third month. Okay, whoa, let's check this out. We get some information now. We got some t and y. When it was 0, we know it was 4080. Now, it says in the third month. Okay, so they're giving us information. There were 10,000 hits. Okay, so now it says find the value of k. Use the result to predict the number after 24 months. So basically, our goal is to figure out what is it when t is 24. So we do just what we did before. Y equals y sub 0 e to the kt. But they actually gave us this equation. They gave it to us over there. So we know it's y equals 4080 e to the kt. I need to figure out k. To figure out k, I'm going to use 3 and 10,000. All right. So then I'm going to go through and do solve for k. So divide by sides by both sides by 4080. I have no idea what that is. I'm just going to kind of let it go. So I get 10,000 over 4080 equals e to the 3k. So now I'm going to ln both sides. $40.80 equals 3k, and divide by 3, and we get k to be approximately whatever the ln of 10,000 divide by 4080. Okay, and divide that by 3, so I get 0.299. So that's my k. So that means my model is y equals 4080 e to the 0.299 t. So that's kind of like the first part of this problem. The second part is to figure out when t is 24. So I grab my handy dandy calculator. And I'm just going to plug it in. So 4080 e to the 0.299 times 24. And it looks like, oh, that's a whole lot of hits right there. So that looks like 5 million. Wow. So we get 5,335,281. So 335, 380, it was 81. Let's round it up. So there's your amount of hits. Over 5,000 hits on a, that's basically just clicks, is when you guys hit on a website, when you actually just click it or visit the page. So there's that one. Great exponential modeling equation. I like it. The next one we're going to do is number 39. It deals with bacteria growth. Again, bacteria growth and bacteria decay. Very, very closely related. So number n of bacteria in a culture is modeled by, and again, it's given us the equation. We now know our initial value is 100 because it's given to us. T is the time in hours in this case. So now it's given us another point where n is 300, t is 5, and it wants us to figure out how long it's going to take to double in size. Well, we have a t and an n column. We know when t is 5, n is 300. They gave us that. But it wants to know what time is it for this thing to double. Well, if the initial amount is 100, it wants to know how long is it going to take for this thing to be 200. Okay, so again, we're going to use the equation that it gives us. It's very similar to the graph one we did in the past equation. So we're going to use that 5 and 300 to figure out k. So we get 300 equals 100 e to the k times 5. Divide both sides by 100. So then we get 3 equals e to the 5k. And then we ln both sides. So we get the ln of 3 equals 5k. Divide both sides by 5. And we can figure out what our k is. So our k is going to be the ln of 3 divided by 5. So we get 0.219. Let's round it up to 0.220. So our model is n equals 100 e to the 0.220t. But now we know we want it to be 200. So we're going to say 200 equals 100 e to the 0.220t. And now I'm just solving for t. Last time I was solving for k over on this side. Now I'm going to solve for t. So divide both sides by 100. And I get 2 equals e to the 0.220t. And to get that exponent down, we ln. Okay, and the ln and e on this side, remember, cancel out. So I'm going to kind of jot it up here. So we get the ln of 2 equals 0.220t, and divide both sides by 0.220. Grab your calculator. I'll say the ln of 2, divide by 0.220, and I get 3.151. So t is around 3.151. I think this was hours in this problem. So that would be the answer. Okay. Kind of a nice one to be doing as well. I think the last one we're going to be doing before we actually do like what we would have done as an activity or like a big U try at the end of class in school would have been like a handout here, and it's actually about the population of East Long Meadow. But before we do that one, we're going to do the population when it comes to endangered animals. And that's number 49, and that's on page 267. So this is what you would have. So it's talking about 100 animals of an endangered species, and to me it looks like some kind of wolf into a game reserve. Okay, the organization believes that the preserve has carrying capacity of 1,000 animals, and the growth of the pack will be modeling by, here's the curve. They gave us some curve. It's insane. All right, but that's okay. They gave it to us. We're going to use it. So I'm going to jot that down. So it's a P of t is 1,000 over 1 plus 9 e to the negative, what is that, 0.1656 t. That's one heck of an equation. So part A says estimate the population after 5 months. So after 5 months, I'm just going to plug in t equals 5 and see what I get in that equation. So 1,000 divided by 1 plus 9 e to the negative 0.1656 times 5. Notice my use of parentheses here. You be very careful with those, right? So it looks like I got around 202 to 207, 2.7. So maybe we can round to 203. So P of 5. Oh, but it does say to estimate. So I guess we could have we're supposed to technically look at the graph. But the math is telling us it's around 203. But let's take a look at 5. If we kind of come up, oh yeah, that's basically 200. Part B. After how many months will the population be 500? Well, you can kind of estimate here. And it looks like it should be around 13 months or 13 and some odd. But again, we can solve that using our equation. We want it to be 500. So I'm making the whole equation equal to that, and I'm going to solve for t. All right. So here, if you ever have a variable in the denominator on one side and you don't have a denominator on the other, you really just swap these two. So I get 1 plus 9e to negative 1.656 t equals 1,000 over 500. And 1,000 over 500 is really just 2. Okay. And then I'm going to go, I don't know why that dot's there, subtract 1 from both sides. And I have 9e to the negative, that's supposed to be not 1 point, just 0.1, sorry. So 0.1656 t is equal to 1. Divide both sides by 9. So I get e to the negative 0.1656 t is equal to 1/9. And I have to do the ln. I feel like we're doing the same steps over and over again. Negative 0.1656 t equals the ln of 1/9. I don't know what the ln of 1/9 is, but I know it's some decimal. But I still have to divide by negative 0.1656. So, ln of 1/9. Oh dear, plug that in. Divided by negative 0.1656. I'll say get around, well, we estimated 13, so 13.268 months. So t is around 13.268 months. Beautiful question. Now the thing is, do we do part C? No, I'm good. I like the next problem I have for you. It's about chocolate. I still have a lot of chocolate left over because we bought all this candy to do an Easter egg hunt, and when it's just my son, we didn't want to give him all the eggs, so there's a lot of chocolate left in my house right now. So let's talk about chocolate bar. This deals with Half-Life. It's not the video game Half-Life, but really all Half-Life is the value of t, or the amount of time it takes for the OG, or the original value, to be half. So the amount of time it takes to get half of the original amount. So we have a 35-gram chocolate bar. We're just going to say, perchance, the half-life of it, if you left it alone, is 2 years. So after 2 years, it's half the size it used to be. Okay, how many grams will be left after 10 years? Okay, so the way you want to think about these are just like the first ones. Again, when x is 0 or t is 0, when time is 0, you have 35 grams. But when it's 2 years, it's half of 35, and half of 35 is 17.5. Okay, so now we can use these two pieces of information to get our model. So we have y sub equals y sub 0, which is 35, e to the kt. Okay, and I guess, again, this really shouldn't be x, this should be t. So to figure out what k is, I plug in 17.5 is 35e to the k times 2 in this case. Divide both sides by 35, and I get 1/2, which, hey, I'm dealing with a half-life problem. You should probably always get 1/2 e to the 2k. ln both sides. So I get the ln of 1/2 equals 2k, and divide both sides by 2. So k is the ln of 1/2 divided by 2. So negative 0.347. So that means our model is y equals 35 e to the negative 0.347 t. And now it wants to know how much is left after 10 years. Well, I'm just going to sauce a 10 on in there for that t. So 35 e to the negative 0.347 times 10. And it looks like I get 1.089. So plug in if t equals 10, I get y to be 1.089 grams. Cool. I'm almost up to a half hour, and I don't want to give you guys too much. So, like I said, the last thing I actually typed out, and it dealt with the U.S. Census and the East Longmeadow. If you want to try it, you can. If you want to stop the video here, I'm not teaching you anything new that you don't know. But it is kind of a cool problem. But there's nothing new. So if you're cool with, if you understand everything, don't worry about this problem. If you want to give it a shot, give it a shot. All right. So according to the U.S. Census, the population of East Longmeadow in 2000 was 14,100. And then this says key. This is key here. Let the year 2000 be t equals 0, because in our equation we have kt. In the most recent census, which is technically 2010, because they haven't finished this year's yet, and I've looked, was 16,287. So it says to use this model to predict what the population will be in 2020. So in 2020, you have to figure out what t is. But if the year 2000 was t is 0, that means the year 2020, t is 20. Okay? So what we first have to do, again, is use that equation, our exponential modeling equation, to figure out what k is. So I get 14,100 equals, oh, not that, y equals 14,100 e to the kt. Okay, because that's my initial amount. Right, and then it's telling me in 2010, when t was 10, I had 16,287. So at 16,287 equals 14,100 e to the k times 10. Divide both sides by that 14,100. And that's some kind of decimal. I don't know, but I get the ln of 16,287 over 14,100 equals 10k, and divide both sides by 10. I just plug it into the calculator. Divide by 10. It's a really small k. Yeah, that looks okay, right? 16. All right, so we get k to be 0.014. So now we have an equation, 0.014, and I want to figure out when t is 20, so I'm just going to plug 20 in right away. Grab the calculator and type it in. So it looks like I get 18,656. And I guess we'll find out if that's true or not once the census information actually comes out. The other kind of the stuff you can do with this is to figure out how long it's going to take for a population if we continue with the same model to reach a certain number. So we can figure out how long it's going to take for the population of East Long Meadow to reach 30,000. So to do that, we're going to use our same equation, that 14,100 e to the 0.014t. That's our model. But now we know that y is 30,000, not 20,000, you moron. And then you just solve for t. So you get that crazy decimal, but we're going to have to ln it to get that exponent down. And divide both sides by 0.014. And then grab the calculator. ln of 30,000. Divide by 14,100. Divide that point 0.014. Oop, don't need that parenthesis. Let's see, we got 53.93. So what that means is around the year 2053/2054, East Long Meadow should have a population of around 30,000 people. And again, that's only if the model sticks throughout that time. All right. So again, this was one video of the 2 for this week. If you guys have questions, you let me know where to meet. We'll see you. Oop, gotta stop it.